Hello, you are welcome once again. We look at our tutorial question 7 on our series on abstract algebra. So the question goes, the integers 5 and 15 are among a collection of 12 integers which form a group under modulo 28. List the elements. Well, they are saying that it is a group under modulo 28, and they are saying we should list the elements. So if you look at this, they didn't actually tell us whether it is a group under addition or multiplication, but then they are saying that it is a group of 12 integers. Well, if we take a group, let's say we assume that Z28, we are looking for Z28, and we are to list the elements of Z28. So Z28 are about 28 elements, which is not true for the 12 integers they are saying. So Z28 will not be the group. And let's say that we have a group of multiplication. Let's say U28, a group of multiplication. And you know that the group of multiplication consists of all the elements which are relatively prime to 28. By now you should be familiar with the word relatively prime. When we say relatively prime, it means that if you have two elements and then the only common element between them is 1, then we say that those elements are relatively prime. For instance, 1 and 2, the only element they have in common as a factor, or the only common factor, is 1, because the factors of 1 is 1 and the factors of 2 are just 1 and 2. And 3 is relatively prime to 2 because the only factors of 3 are 1 and 3. So they only have 1 in common. So we are looking for all the numbers less than 28 which only have a factor of 1 in common with the 28. So all numbers less than 28, but those numbers will have a factor 1 that is common between itself and 28. So we are saying those numbers are relatively prime to 28. Is that okay? So 1 will be the first number, because if we take 1 and 28, the only thing they have in common is 1. Now 2 cannot be, because 2 and 28 have a common factor, because the factors of 28, actually 2 is part of them, so 2 cannot be part. So but if 3 is part of the numbers, 5 is part, 9 is part, 11 is part, 13 is part, 15 is part, 17 is part, 19, 23, 25, and 27. These are the elements of U28. And let's count them and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. That is the 12 integers. These are the integers they are talking about. And they are saying that they are under modulo 28. And you can see that they are actually under modulo 28. Now, they are saying that they have integers 5 and 15. So this is our 5 and this is our 15, and actually they've satisfied the condition that they specified. And so these are the members of our group. That is all for that particular question. Now we come to the next question, which is under permutation groups. Now they are saying that I'm giving alpha to be equal to 2, 3. So alpha equals to 2, 3, and then beta is equals to 1, 2, and 3. They are saying we should compose alpha beta. So we should compose alpha beta. Actually, in order to compose, we have to rewrite this back into the symmetric group elements the original way. And this one, you know what it will be. Let's say alpha is the same. So alpha, which is 2, 3, is the same as this is the same as probably 1, 2, 3, like this. You know, always the top elements are 1, 2, 3. But it seems since the 1 is not there, it means the 1 is fixed. So 1 is here, but 2 goes to 3. So 3, 2, like this. And so this is the element for alpha. Now the element for beta, which is 1, 2, 3. Of course, the top elements are always 1, 2, 3, like this. But if you look at this, 1 goes to 2, like this. And 2 goes to 3. And 3 goes to 1, like this. And so if you want to go back 1, like you are going, this one, you could have come here. Let's say you could have come here, and this one goes here, come back, goes here, like this. And so that is why we're having 2, 3 here. But here we have 1 goes to 2, 3, 2 goes to 3, and 3 goes to 1, like this. We come back here. And so we have 1 to 2, then to 3, like this. And so these are our two elements. If we want to compose them, then that will probably mean we have alpha, beta, which is equals to, just like multiplying, then that's the composition of these things. So we have 1, 2, 3, 1, 3, 2. We are just multiplying, then that's the composition. 1, 2, 3, 2, 3, 1. And so if we are composing, the top elements will always be 1, 2, 3, like this. Is that okay? And so, but now see, 1 comes to 2, 2 comes to 3. So the first element goes to 3. Now 2 comes to 3, and 3 comes to 2. So the second element goes to 2. Now 3 comes to 1, and 1 comes to 1. So the third element goes to 1. And so rewriting this one, our thing becomes, so here we come 1, 3. So 1 to 3, 2 is fixed. So we have 1, 3 as our element. So we have composed it. Now they are saying that we should find the inverse. As for the inverse, I think I'll stop it here. Then we'll look for the inverse in the next video. Thank you for watching. Kindly subscribe.